So today we're going to study one of the most important examples of Boolean algebra or of binary circuits digital circuits that there are, because we're going to talk about binary arithmetic, and in particular we're going to focus on binary addition. Now you might think of addition as, quote, mathematics, and binary gates as being, quote, logic, but it turns out that logic can be used to implement arithmetic, and that's probably one of the most important lessons to take away from today, is that the process of addition is a very mechanical process. It's very rules based, and anytime that you have rules, you can implement it using Boolean algebra. So let's consider first of all the four cases of binary addition. Of course, since there are only two numbers being added, we're not allowing a carry in this example. If there are only four numbers being added, if there are only two numbers being added, then there are only four possible combinations. And you can see here 0 plus 0 yields a 0. I'm showing a second bit here to allow the possibility of a carry out. 0 plus 1 yields a 1 with no carry out. 1 plus 0 yields a 1 with no carry out. And 1 plus 1 yields a 0 with a carry out of 1. Or you could say 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 2, because this is a 2-bit binary number that's used to represent the number 2. So in this case, we don't have a carry in. There are only two inputs, and there are two outputs. There's the sum bit, which will be this least significant bit, and then there's the carry out bit, which will be the most significant bit. Now, if we do allow a carry in, and you can see here I've shown the carry in on the top here with this tiny number. If I do allow a carry in, now there are 8 cases. So I can have 0 plus 0 plus 0 gives 0, 0 plus 0 plus 1 gives 1, 0 plus 1 plus 0 gives 1, 0 plus 1 plus 1 gives 2, 1 plus 0 plus 0 gives 1, 1 plus 0 plus 1 gives 2, 1 plus 1 plus 0 gives 2, 1 plus 1 plus 1 gives 3. So this would actually be a pretty decent thing for you to have on your notes for the next exam. Unless these calculations are second nature to you, then you won't need that, of course. So let's consider how do we apply those rules if we're going to do multiple bit addition. Well, I'm going to see here I've got 1011 and 1001. Well, if I do 1 plus 1, I always start with the right-hand digit, just as we do in regular addition and decimal addition. 1 plus 1 is going to give 2, which is a 0 with a carry out of 1. 1 plus 1 plus 0 gives a 2, 0 with a carry out of 1. 1 plus 0 plus 0 is going to give a 1 with a carry out of 0, or no carry out. I could have just left that blank. 0 plus 1 plus 1 gives a 0 with a carry out of 1. And in this last digit, there's nothing to add to it, so the carry out just comes down here. And if we do the conversions, we see that 1011 is decimal 11, 1001 is decimal 9, and 10100 is decimal 20. And while this may not sort of be right at the tip of your tongue, I'd like to think that 11 plus 9 equals 20 is something that you've mastered for at least several months. So we have now the possibility of being able to do binary addition. You probably could have figured out how to do this on your own, but now you've had a bit of a more formal introduction to it. It's time for you to do a couple of example problems that will give you some practice with doing this sort of addition. And in particular, while you're doing those example problems, you might want to keep figure 2 right in front of you.